Hi my friends, today we model this part. It is symmetrical on two directions, and this is the drawing. We create firstly this bottom flange with dimensions 2 to 8, radius 18, and width is 76, not 86. This is 86, this is 76. And the thickness of the feature is 14. This part is number 54 from my collection of 100 mechanical parts. New empty document. Take a look of this workbench and select CAD, not Blender, because we create mechanical parts. New sketch, XY plane, and we create half of that part because of the symmetry. Horizontal, go here, then to create a tangent arc for continuation, then to go at this level, and we apply tangent here. Same horizontal for this point and this center point. Equal are these two sides, and symmetric for this point and this point and this axis. Dimensions. This is 2 to 8 divided by 2. This is 76. And this is 176 divided by 2. Radius 18, you remember. Now we have a fully constrained sketch. Close and pad or extrude on 14. Next is this cut, you see, 162 divided by 2 will be on 4 and 45 degrees. We select this face for a new sketch, then we use existing entities. We start with a polyline from here, going somewhere here, then sloped, back, horizontal, and close here. The angle is the first of 45. Then this is 162 divided by 2, and this is 4 millimeters. Close. Pocket not this depth, but through the part, through all. Okay, now we create this body. Dimensions 76 on 176. We have these dimensions, and this line connects these two sides. The height of this is 102 minus 14. We select this face for a new sketch. We project this line and this line, and we simply draw a rectangle starting from this corner to this corner. Close. Pad or extrude 102 minus 14. Then we add this contour with a thickness of 12. That contour is dimensioned with 180 on 90. Yes? Don't forget radius 5 to each corner. Good. This face for a new sketch. We draw a rectangle starting from this axis to outside the other rectangle, symmetrical this point and this point about this axis. Dimensions, this is 180 divided by 2, and the other one is 90. Fillet between these two lines and between these two lines. They are equal. This arc has the same radius with this arc. The radius is 5. Close, extrude or pad to the other direction on 12. Next is this internal void. Dimensions 160 on 60. The depth is 75. Nothing simpler. This face, new sketch, rectangle on 160 divided by 2, enter on 60. Symmetry, this point and this point about this axis. Close, pocket 75. Now we place this hole with the counter bore 28, 16, 2 millimeters. We select this face, hole 16, through all, counter bore 28, on 2 millimeters. Okay. Now we add this feature. Dimensions are here. Radius 50, above fillet 18 and 13. This face for a new sketch. Project some lines 1, 2, 3. Then polyline starting from this point to here, a vertical MMM, large arc going here and back to the start. We make horizontal this line and we place dimensions. This is 18, this is 50, and I move this up to place a dimension of 13. Close, extrude or pad. The distance is parenthesis 86 minus 76 parenthesis divided by 2. We don't invent dimension, we use dimensions in the drawing. Okay, you see here 86 minus 76 in parentheses divided by 2 to obtain this small distance. We continue with this feature. It is 60 with a thickness of 14, placed at 72 divided by 2 and 63 from the bottom. We select this face, new sketch, see inside, circle, diameter of 60, placed at 72 divided by 2 and 63. Close, pad or extrude on 14. Good. Now we mirror these two last features. I press the Control key to select the second one because we want to apply mirror about XZ plane. We select here XZ plane. Okay, now you see we have two double entities here. Now this hole through all the part. The hole is 32 placed at 72, which means in the center of this boss. So we'll use that feature to find the center. We create a new sketch here. Then we project this circle to create another one with diameter of 32. close, and we use pocket or hole. Pocket now. Dimension is through all. Okay. Now we use this dimension metric 8, depth 8 for one hole of these 4 holes. We select this face, new sketch, project this circle, then we place another circle here, no matter what is the diameter, but it matters that these 2 centers to be on the same vertical. I forgot to tell you the diameter here. It is 44 and we divide it by 2. Close, hole, isometric regular profile, metric 8, and threaded. You see now here is a diameter of 8, but when I select threaded, that diameter is smaller. I don't place here model thread because this makes a complicated work here. You can select model thread to see inside that profile. 8 is the dimension of this hole, metric 8 on 8 as a depth. Okay, now we use circular pattern or polar pattern of the selected hole. Then we select a reference, which is this circle. You see now 2 holes. We want to have 4 equidistant holes. Okay, now we'll try to mirror these 4 holes to be here. You will see that we have problems with this operation. We select polar pattern. This is the last feature, yes. We can select also this hole, the base of the polar pattern, and we apply mirror. You see here only additive and subtractive features can be transformed. I tried this 3 times. I cannot multiply by mirroring these 2. Yes? I don't know why this is not possible, and I hope you will help me, because we'll learn together FreeCAD. I am new in FreeCAD. I use Inventor, but FreeCAD is only for you, and I am happy to have friends who help me to use this, to create tutorials for this. If you have a solution for this, please let me know in comments of the description of this tutorial. what to do now? I have only a solution. I select this face, I create a new sketch, I project this contour, I create a circle, I place it on the same vertical with this, then I place that dimension of 44 divided by 2, just as before. Then close, because the diameter is not important. We use hole, we apply isometric regular metric 8 thread, then the depth of 8, and we apply thread it to change the diameter here to be inside the thread. Okay, then we select the last feature, which is subtractive or additive. This is additive. No, this is subtractive. Yes, we subtract something when we create this hole. And polar pattern, selecting the reference, this reference, and placing here 4 occurrences. Okay, now we add these bosses, radius 10 and thickness of 12. This face for a new sketch, then we project 1, 2, 3 lines, circle of 20 divided by 2, and another circle. They are equal, and we have to trim this arc and this arc. Then we draw a line, a simple line, and another one to here. Then we go down for a new line and another one. Okay, close, extrude or pad the other direction on 12. Okay, now I want to apply mirror for all these features in order to obtain the full part. Take a look what happens, my friend. I select directly this without selecting anything here. I select this face, YZ is the name, and I obtain all this part, including these features. Yes, why I can do this now and I couldn't do this before? I'm waiting for you to give me an answer, my friends. Now we have to apply these 6 holes with this definition, metric 8, depth 8. Take a look here where the distance is 75, because the others are in the centers of bosses. This face for a new sketch, we project each boss, this one, this one, this one, and this one, and we have centers, circles, 1, 2, 3, 4, and other 2 on this axis, no matter what is the diameter. But it matters for these 2 to be symmetrical with this axis and at a distance of 75. Good. Close. Different holes, yes? Different diameters. Yes, but we use the tool hole, and all of them are at the same diameter of 6. No, we don't want to be 6, we want to be metric 8. And the depth, no metric 8, metric 10. Excuse me. And the depth is 9. We select threaded and you'll see that the holes are different. Okay. This is too small, I think. Okay. Let's go back to that features. This is the sketch. Double click. And the diameter is not divided. Okay. Close. That's all for today. Thanks for watching. Bye bye.